Let's talk about capacitor. Capacitors are used commonly and useful as an electronic component in the modern circuits and devices. The capacitor has a long history and usage, with more than 250 years ago. The capacitors are the oldest electronic component being studied, designed, developed and used. The discovery of capacitor begins in 1745 with Leyden Jar experiment. At that time, one way of generating electricity was to use a friction machine. Many scientists were trying to store this electricity in some jar. First, von Kleist of Pomerania, a German scientist, did the experiment with the friction machine, where static electricity produced by the rotating glass sphere was conducted by the chain through the suspended bar to the alcohol in the glass held by Mr. von Kleist. During the experiment, he unknowingly touched the suspended bar and felt huge powerful shock. Von Kleist found that touching the wire resulted in a powerful spark, much more painful than that obtained from an electrostatic machine. Again in 1746, Peter van Musschelbroek along with his student Andreas Cornelius at Leiden University tried this experiment, while his student, Andreas Cornelius, was holding the jar. He also was impressed by the power of the shock he received, writing, "I would not take a second shock for the Kingdom of France." After this experiment, they named this jar as Leyden Jar. Till this time, they assumed that the alcohol or water inside the jar can store huge charge, but they were unable to conclude anything. Benjamin Franklin investigated the Leyden jar and came to the conclusion that the charge was stored on the glass, not in the water as others had assumed. Leyden jars were later made by coating the inside and outside of jars with metal foil. In the 1830s, Michael Faraday did experiments which determined that the material in between the capacitor's plates had an effect on the quantity of charge on the capacitor's plates. He did these experiments with spherical capacitors, basically two concentric metal spheres in between, which he could have air, glass, or any other materials. And Coulomb's law was already discovered in 1785, which states that the magnitude of the electrostatic force of attraction or repulsion between two-point charges is directly proportional to the product of the magnitudes of charges, and inversely proportional to the square of the distance between them. Using this Coulomb's law, Faraday had effectively measured the charge on the capacitor when the gap between the spheres was filled some air or some other material. And, during his experiments, he found that for the same potential difference, charge was greater with other materials than the air. For Faraday's this work, the unit of capacitor is known as farad. A capacitor is a device that stores electrical energy in an electric field. It is a passive electronic component with two terminals. Passive device means a device that cannot generate power. Instead, it dissipates or can store energy. Or, we can say that the capacitor is a passive component and it stores the electrical energy into an electrical field. It is made up of two close conductors and separated by the dielectric material. If the plates are connected to the power, then the plates accumulate the electric charge. One plate accumulates the positive charge and another plate accumulates the negative charge. The effect of the capacitor is known as a capacitance. A capacitance of 1 farad means that 1 coulomb of charge on each conductor causes a voltage of 1 volt across the device. What happens when we connect capacitor in series? Its value gets decreased, and the value can be calculated as per this formula. And capacitor value gets added up when we connect capacitors in parallel. Capacitor charging circuit. Capacitor starts storing charges as soon as we connect a resistor and capacitor in series with the battery. And the potential difference can be calculated across the capacitor. This is the capacitor charging graph for voltage and current versus time. Initially, it offers very less impedance, almost zero, which causes very high current flow through it, and charge are being stored on capacitor very rapidly. That is why voltage across the capacitor suddenly increases at initial time. After few moments, when capacitor stores charges maximum of its capacity, and voltage across it gets stabilized, current does not flow afterwards. When voltage source is removed from this circuit, charged capacitor energy gets dissipated across the resistor. Again here, charges move exponentially from capacitor towards the resistor, and same you can observe from this discharging graph. Initial current is very high and reduced exponentially. Till now, we went through capacitor history, what it is, and saw few circuits. Now, let's have a look on different types of capacitors and its usages. Capacitors are mainly divided among polarized and non-polarized capacitor. A polarized capacitor has polar terminals called anode or positive terminal and cathode or negative terminal. There are many subtypes of capacitors, but I will mention only few of them which are commonly used. Electrolytic capacitor, ceramic capacitor, Film capacitor. First, let's talk about electrolytic capacitors. They are polarized capacitor. Its anode or positive plate is made of metal that forms an insulating oxide layer. This oxide layer acts as dielectric of the capacitor. There are three different anode metals in use for electrolytic capacitors. Aluminium electrolytic capacitor. These capacitors are used when a large capacitance is required and leakage current is not an important factor. Typically used in power supplies and DC-DC converters. Tantalum electrolytic capacitor. Applications using tantalum capacitors take advantage of their low leakage current, high capacity and long-term stability and reliability. For example, they are used in sample and hold circuits which rely on low leakage current to achieve long hold duration. Niobium electrolytic capacitor. This niobium electrolytic capacitor is also used for more reliable and stable circuits, as it operates reliably over a wide temperature range without large parameter deviations. Next, let's see another kind of capacitor called ceramic capacitor. A ceramic capacitor is a fixed value capacitor where the ceramic material acts as the dielectric. Ceramic capacitors offer high stability and low losses for resonant circuit applications. Here, resonant circuit means an electric circuit which has very low impedance at a certain frequency. Film capacitor. A film capacitor is a capacitor that uses a thin plastic film as the dielectric. They are relatively cheap, stable over time, and have low self-inductance. Film capacitors are widely used because of their superior characteristics. This capacitor type is not polarized, which makes them suitable for AC signal and power use. Film capacitors can be made with very high precision capacitance values, and they retain that value longer than other capacitor types.